Hey, AP Chemsters, this is Mrs. Vandelay bringing you the Blankwell edition for Chapter 1, Section 7. And this is the reliability of a measurement. And hopefully this brings back memories of one of the first activities we did on the second day of school when we were looking at all the different equipment. And what made a burette more precise than the beaker? And it was how many different markings there were on that particular measuring device. So we need to be able to read our equipment correctly. And it says scientific measurements reports that every digit is certain except for the last, which is estimated. So here we have a graduated cylinder shown that has a marking of every 0.1 milliliter. How do I know that? Well, here's my 4, here's my 5, and there are 10 markings in between the 4 and the 5. Well, it's a tenth of a milliliter then. So it says report to the volume to the correct number of sig figs. So I am certain that this value is, well, here's 4, this mark right here is 4.5. So the bottom of the meniscus is, I would say it's between 4.5 and 4.6. So I need to report it one more digit. So I need to go to the nearest hundredths. So it's estimated. So is 4.55 milliliters acceptable? Is that between 4.5 and 4.6? Yes, it is. Is it to the nearest hundredth of a milliliter? Yes, it is. So I read that correctly. So why don't you go ahead and read problem number 18 and do it on your own. See what you get. All right, this is what I got. So again, there are 10 measurements between the 2 and the 3. So if this is 1 centimeter, right here, then each of these lines in between is a tenth of a centimeter. So I can go one more digit later. So this is 2.0, this is 2.5, 2.6, 2.7, 2.8. So what I'm looking at is that line is between 2.7 and 2.8. I can go to the next digit, so it's a 2.75 centimeters. Hey, but Mrs. Vanderwilly, I think it's closer to 2.72. Is that okay? And the answer is yes. Why? Because that last digit is estimated. By giving me that value, I know my heart of hearts that the value is between, 2.7, 2.8. It's in the nearest hundredth of a centimeter. So yeah, 2.72 is just as good as my answer, okay? So don't worry. So in problem number 19, we're going to do this in class. It's going to be fun, all right? So we can't do this now. So let's go on and count sig figs, all right? So get used to these rules. This is not the first time. I know you have seen sig figs in your first year chemistry class, but this is a review of what this is. And does the AP worry about sig figs? And the answer is yes, of course they do. So we need to do this now, and we need to be consistent for the rest of the year, okay? So rules for determining number of sig figs: non-zero digits will always be significant. If they weren't, you can't measure them, okay? Interior zeros, so zeros in between two non-zeros are significant. Now watch this next one. The leading zeros to the left of the first non-zero digit is not significant. They are placeholders. So remember when we convert between meters and millimeters, what happens to those preceding zeros if I were to convert units? They disappear, okay? So they're placeholders. Trailing zeros, careful. If you have a decimal point and the zeros follow that decimal point, they are significant. How do I know that? Because I'm telling you, when I have this value of 45.000, the instrument that I can read can go nearest thousandth of a whatever, okay? Maybe of a gram or maybe of a meter, I don't know. But those zeros tell me the precision of my instrument. Trailing zeros before a decimal point and after non-zero will be significant. But what if I don't have a decimal point? What if it's just implied? Because that is 1,200. But what if I don't have a decimal point? Then my instrument can only read to the nearest hundreds of, whatever pounds or grams or something. So the rest of it is just guesstimated. Okay, it's about 1,200. So those zeros are not significant. They're just indicating that the one is in the thousands position there, okay? So exact numbers have no certainty, okay? They're accurate as in counting. We can only have a whole number per person, otherwise it's gross. a defined quantity, like all those things that we saw earlier, like 100 centimeters, 1 meter, a million, what would that be, micrometers is 1 meter. So those are defined, it's a definition, they are not, you didn't measure them, okay? And then numbers from an equation such as a diameter, 2 times the radius, that 2 is not a measured quantity, so there's no sig figs. The value of the radius would, but not the 2. So let's go ahead and I'm going to do the first couple with you and then you do the rest. So in letter A, how many sig figs do I have? Well, if you go back and look at your rules, these zeros are not significant. They're placeholders. But the zeros here that follow the 5 is significant. So if I were to count them up, I have the 4, 4, 5, 0. I have 4 sig figs here. Okay, well, I'll go across. Over here, how many are significant? They all are. All 5 of them are. Why? Because the zeros are between 2 non-zeros. Okay, they have to be. Over here, letter C, this is a definition, so it's an undefined. So make your little, let's see if I can't do that. Your infinite. So it's infinite number of sig figs. Okay, so that's how I would represent an equation like this. Okay. How about letter D? If you have scientific notation, only look at the coefficient. So those zeros are trailing the decimal point. All 4 digits are significant. So go ahead and do the rest. And, well, pause this, do the rest, and then I'll give you the answers. Okay, so go ahead and pause this. All right, let's see how you did. Letter E, only 1. All the zeros that precede the 2 are just placeholders. Letter F, only 1. That's a comma, not a decimal point, so it's about 10,000 meters. It's not exactly 10,000. If I wanted to be exactly 10,000, this is what I would do. I could do 1 of 2 things. I could put a decimal point right here, and so all those digits are significant, or I could have put a line over it. Something like this. And how handy that is what if I only had 3 sig figs? What if my measuring device could only go to 3 sig figs? Then I'd put a line over that 0, and that tells me that these digits are significant and the ones following them are not. You could also write it in scientific notation with 3 sig figs. So you can say 1.00 times 10 to the 4th, and that would also give that to you. But as written, as you probably did the problem, it's just 1 sig fig. Was it letter G? It's all 3. I don't have any zeros. Don't worry about it. Letter H is, again, infinite. Why? Because you're counting your pennies. You do not have fractions of pennies. It can only be whole number of pennies, okay? Letter I is 3. You're only looking at your coefficient, 1.01. Letter J is only 2, the 9 and the 9. All those zeros that precede it are placeholders. Letter K is 3. All of them are. So I measured to the nearest hundredth of a kilometer. So all 3 of them are significant. And letter M, only 2 of them are, the 2 and the 1. The rest of the zeros are placeholders. Hopefully you did all right. We will certainly be practicing these, don't worry. Now, why do I worry about the number of sig figs? Because it isn't enough to know how many sig figs there are. What we're looking at is we're going to be calculating. Most of this year, we're going to have a calculator in our hand, and we're going to be calculating, so how do I report those digits? Well, you have 2 rules you really have to worry about. Multiplying and dividing is one rule, and adding and subtracting is another rule. So when you do multiplication division, you have the term with the least number of sig figs. The least accurate measurement determines the number of sig figs. So when you're doing multiplying and division, it's how many you have. How many sig figs do you have? So in the case here, you have 3 sig figs. You have 2 sig figs. Well, what's smaller, 3 or 2? 2. So this is what your calculator gives you. So now you have to round it to 2 sig figs. So your answer is 6.4. To add and subtract, let's see what we do. Let's turn the page. And it says the term with the least number of decimal places, not the least number of sig figs, but the least number of decimal places, or the least accurate measurement, we determine the number of sig figs in the answer. So here I have to the nearest 100th, 10th, and 1000th, which is my least accurate measurement, is to the nearest 10th. So my answer should be to the nearest 10th. So that's why it's 31.1. Not because 18.0 has 3 sig figs, it's because where the 0 is. So when you add or subtract, it's where it is. When you multiply or divide, it's how many you have. And rounding, hopefully you do know how to round. If you have to round the last digit is 4 or less, you don't round up. If it's greater than 5 or 5 or more, like a 7, you round up, okay? Now note, 5.349 rounds only to 5.3. Don't say, well, the 9 rounds up to a 5, the 5 rounds up to a, no. You only look at the digit just following the spot where you want to round it. So if you're going to go to the nearest 10th here, you only look at the 4, and it's 5.3 then, okay? So you don't round up. So let's look at these problems here. I gave you the answers for you. This is what my calculator gives me, okay? All those decimal points. So what is our rule here? We're multiplying. So it is how many? Hopefully you said that. So you have 3 sig figs, 4 sig figs, 2 sig figs. Well, what's your smallest number? 2. So my answer should have 2 sig figs. So you go 1, 2. So it's 270. Now do you round up to 280 or do you keep it at 270? So you keep it as is. So your answer is 270 centimeters cubed. Oh, I almost forgot. 270 centimeters cubed. So you can write that down. So what do you do in number 2? I already gave you what your calculator gives you. So how do I deal with this? Well, I have to look at that last decimal place. That's in the thousandths, the hundredths, the thousandths, the tenths. So which is my least accurate placeholder there? It's in the nearest tenths. So I go to the nearest tenths. So I get 48.3 meters. Okay. So what about step D? Let me scroll down here. Okay, so in letter D, it says to avoid rounding errors and multi-step calculations, round only the final answer. Okay, that's only you round. You still have to use your sig figs, but you just worry about rounding at the end. So in number 1, do you remember what the rules of math is? What should I do first? You do what's in the parentheses first, okay? So go ahead and subtract that out. So this is what I get when I subtract it out, but what's wrong with this value here? This is to the nearest thousandths. This is to the nearest hundredths. What should this answer right here in the parentheses be? It's not 0.479. Because of the placeholder right here, the 1, that's the hundredths, you go right here to 0.48. Now you have 2 sig figs here. And when you multiply 6.78 by 5.903 times 0.48, what does your calculator give you this time? So when I take, again, 6.78 times 5.903 times 0.48, I believe this is what you get. Now that's what my calculator gives me. Of course, I need to do a little better job than that. So I have 3 sig figs, 4 sig figs, 2 sig figs. So my answer is 19, 2 sig figs. Okay, let's try the next one. What should I do first? You should subtract first. So what do you get when you subtract? I think that's what you get. And now divide, and this is what my calculator gives me. There we go. Ruh-roh. What should my answer be? Here I have 1 sig fig. Here I have 4 sig figs. I'm dividing. What should my final answer have? 1 sig fig. So these are not significant. These are not. Oh, that one's significant. So I need to round up. So my answer is 0.0008, and I'm done. Okay. So go ahead and try problem number 22, and I'll show you my answers. All right, so it says perform each calculation to the correct number of sig figs. Here, let me scroll this. There we go. There we go. So what should I do first? It's all straight multiplying and dividing. I don't really have to perform anything first. So this is what my calculator gave me right here. And now what? I need to count my sig figs. I have 3, 4, 5, 5. So what's my smallest number is 3. So there's my 3 sig figs. Over here, I added them. Those are my numbers from my calculator. I have the thousandths, tenths, 10,000s. I need to go nearest tenths. I'm actually about out of time, so I guess I'll have to quickly finish this up on a part 2. So again, don't wait to be great. Go to part 2 next, okay?